Assalamu alaikum warahmatullahi wabarakatuh. Today we are going to discuss about frictional force. And if you can remember, at the end of our lesson on the just concluded first term, I told you that we have two topics extra for us to discuss in order for us to complete the first term scheme of work. And those topics are, we have the frictional force and we have the factors. I told you that day that you should write it inside your notes. So those are the two topics that we have to discuss in order for us to complete the first term scheme of work. So last week I sent you the notes. I sent you the notes for the friction. So today we are going to discuss all the explanation on the note that I sent last week, which I have the belief that virtually all the students will be able to fill the notes. Now today, the content of today's lesson is the definition for friction, the limiting friction, the types of friction, angle of friction, coefficient of friction, angle of repulse, law of friction. So those are the things that we are going to cover today, inshallah, by the grace of Almighty Allah. So let's start with a friction. What is friction? When we are talking about the friction generally, the friction regarded to as a force that opposes the relative motion of an object. When we are talking about the force that opposes the relative motion of an object in contact with other surface, that is, if an object is having a contact with another surface, are you getting it? And we apply a force to such object. The force that we apply, definitely the object will move in the in the direction of the force that we apply. Therefore, there is a force that is regarded as frictional force, and that frictional force will be the one that will be opposing the force that we apply to move the object, or the force that we apply to move the object in the direction of the force. Okay, so the frictional force will now be the one that will be that will be opposing the force that we apply. And if you can check this sketch now, you can see the pushing force is regarded as the applied force. So the pushing force is applied to this block or to this object, and this is the motion of the that is the motion of the object. So the object is moving on on the right path. Why the frictional force? You can see this is the frictional force is the one that will be opposing is the one that will be opposing the object in order for the object not to move in free motion. Am I communicating? So that is what is regarded as frictional force. Now, according to what we have on the slide, they said when a body slides or tends to slide on a surface on which it is resisting, a resisting force opposing the motion is produced at the contact surface. That is, the frictional force will be will be applicable in the contact surface. That is, the object must have contact with another object, or the object must have contact with with a surface. Do you understand what I'm saying now? So this is what is regarding as as frictional force. So in a nutshell, the frictional force can be defined as the force that is opposing that is opposing the object in contact with other surfaces. Do you get it? So that is what is regarded as frictional force, which I have the belief that you know what frictional force is now. Now, let's talk about the limiting force. The limiting force is the maximum friction force that can be developed at the contact surface. When the body is just on the point of moving, it is called the what? The limiting force. When the body is what? On the point of what? Of moving, is regarded as what? As limiting force. Now, what this is trying to illustrate is that, when we are talking about the object, we have four forces that is acting on the object. We have the vertical force and we have the what? Horizontal force. When we are talking about the vertical force, such as what? The normal reaction. If you remember the card that I dropped for you the other time inside your notes, if you check the card that we draw, I said that we have the normal reaction, which is acting upward. That is on upward like that. You can see this is what? The normal reaction. And we also have what? We also have the weight. That is the weight of such a object. Are you seeing that? The weight of the what? Of the object. So we have the thrust. The thrust can also be regarded as what? As air resistance. We have the thrust, which is on the what? On the horizontal plane. And we have the what? The limiting force on also the what? Horizontal plane. So when we are talking about the thrust and the limiting force, so that can also be regarded as what? As the applied force and the what? And the frictional force. So the limiting force is the one that tends to what? To move the object. Am I communicating? Tends to what? To move the object from one place to another. That is what is regarded as what? As limiting force. And in order for the object to move from a particular place, the applied force must be greater than the what? Than the frictional force. Are you getting it now? But if the frictional force is equals to the applied force, the object will remain at equilibrium point. That is in a static motion. That is, the object will not move at all. That is what we mean by what? By the equilibrium of the object or the static friction. So that is what's regarded as a frictional force. Again, the frictional force is the maximum force that can develop at the contact surface. The friction is showing on the what? On the contact surface. That is, if the object did not have contact with any other object or with the surface, therefore there won't be anything like frictional force, and there won't be anything like what? Limiting force or limiting friction. Do you get it now? So that is what's regarded as a limiting friction. So we have different types of friction. Okay, so we have the static friction, we have the dynamic friction, we have the sliding friction, and we have the what? The rolling friction. Now let me discuss this one after the other. When we are talking about the static friction simply regards to as the what? As the friction when the body is what? Is at rest. That is, the frictional force that we have on the body that is what? That is at rest is regarded as what? As static friction. For example now, you place your book on the table. You are not touching the book. The book is not moving. The book is at the equilibrium. So far the book has contact with what? With the table. There is frictional force. Are you getting it? And that frictional force is regarded as what? Static friction. That is the friction that we have on the object in equilibrium or on the object in what? In static. In the object that is not in motion. Okay, now that is that about the static friction. We also have what we regarded as dynamic friction. When we are talking about the dynamic friction, is the friction experienced by a body when it is in motion. That is, if the object is in motion, there is still a friction. Are you getting it now? So such friction is regarded as what? The dynamic friction. So we have the what? The sliding friction. The sliding friction is experienced by a body when it slides over another. Are you getting it? So when a object is sliding over another object, so the kind of friction that we are going to have in that sense is regarded as what? Is regarded as a sliding friction. So the last one of this type of friction, we have what? The rolling friction. When we are talking about the rolling friction, is when the body is rolling over another. The type of friction that we are going to have on such motion is regarded as what? The rolling friction. Are you getting it now? So examples of static friction, I've made use of your notes placing on the table. Okay, when we are talking about the dynamic friction, a car moving. Are you getting it now? So the tire of the car is having what? It's having contact with the what? With the ground surface. Do you get it now? So if the car is moving, the tire will experience the dynamic friction. Do you get it now? And when we are talking about the sliding friction, that is when you know what a sliding friction is. The examples of the sliding friction is that when we have a inclined plane. Am I communicating? The inclined plane will now displace an object. Okay? Or let me even use something that you students are very, very familiar with. I have the belief that most of you do watch sports. Are you getting it now? So, on the field, when we have a player called Didier Drogba, and you know how Didier Drogba used to jubilate after scoring a goal. Okay? You know it will slide on the what? On the pitch of the field. Are you getting it? So the kind of friction that is happening in that particular period is regarded as what? The sliding friction. Do you get it now? So that about the sliding, examples of the sliding friction. The rolling friction, the ball rolling on the field. Are you getting it now? The ball rolling on the what? On the field or on the ground surface is regarded as what? Is experiencing the what? The rolling friction. So these are the things that I'm saying in essence. You can see this object, there is no moving, the object is not moving, so it is guided as what? The static friction. You can see, and for us to have this static friction, as I said earlier, the frictional force must be equal to the what? To the applied force. Do you get it now? You can see this sketch. This is the static friction, sliding friction, and the what? The rolling friction, the ball rolling. Okay, so that is that about the examples of the types of friction. Okay, so I hope you understand the explanation so far. Okay, now let's talk about the angles of friction. And when we are talking about these angles of friction, you must understand the forces that we have on an object. What are the forces that we have on an object? Horizontal and the what? And the vertical. So when we are talking about the vertical motion, we have the weight and we have the what? The normal reaction. Horizontal, we have the what? The applied force and we have the air resistance. Or we have the frictional force and the what? And the thrust. So if you check the sketch that I showed you earlier, this one, okay? So those are the motion, or those are the forces that we have on the what? On this on any object rather. Now let's now talk about their angles. Okay, we have normal reaction. The angles between normal reaction, you know the direction of normal reaction. The angle between normal reaction and the resultant force. You know what resultant force is as well. It's regarded as what? As the angle of friction. That is what is regarded as what? The angle of friction. Okay, now this is what we are saying in essence now. This where I label as A, that is our what? The direction of what? Of normal reaction. This B is guided as what? As the resultant reaction. Or that B is the direction of what? Maybe the frictional force or the applied force. Are you getting it now? So that is that. Now if we now have this angle, the angle that you are seeing on the sketch is the one that is guided as what? As the angle of friction. Am I communicating? Angle of what? Of friction. Now please check the labeling very well. So we have the angle. You know what R is, right? And we have F. R is what? It's telling us that is what? The direction of the object. That is what? The resultant force, the frictional or the limiting force, and we have the what? The angle. Are you getting it? So this is what is guided as what? As what? Angle of friction. So let me say that again. The angle of friction, the angle between normal reaction and the resultant force, which is R, is called the what? The angle of friction. It is also called the what? The limiting angle of friction. Angle of friction or limiting angle of friction. Please take note of this very well, because we are going to use this to solve series of examples. Okay, all right, so that is that about that. The coefficient of friction. When we are talking about the coefficient of friction, the ratio of limiting force, which is ratio of limiting force and normal reaction, is called coefficient of friction. That is, when we are talking about ratio, generally the ratio is regarded as what? Division. Are you getting it now? That is the limiting force, which is denoted as F. Abi, the limiting force is denoted as F. If you go back to the graph that I just showed you now, okay? And the normal reaction is denoted as what? As N. Why the coefficient will now be what? Will now be this sign. So this is the sign for the coefficient. You can see. So the coefficient of friction will now be equal to what? F all over what? All over N. Why F is the what? The F is regarded as the frictional force or the friction force. Why N is what? The normal reaction. Why this sign is a Greek word. That sign is regarded as mu, okay, or mu. Are you getting it now? So that is the sign that we are using for the what? For the coefficient of friction. Please note this formula. So that is that. The next thing, we have the angles of repose. When we are talking about the angles of repose, with increase in angle of the inclined surface, the maximum angle at which body starts sliding down is called the what? The angle of repose. That is when we have the inclined plane. We now displace the what? The object on an inclined plane. Are you getting it? So definitely the object that we display on an inclined plane, what will happen to such object? The object will slide down. Are you getting it now? So the process of sliding down of the object, are you getting it? The maximum angle that we have in this object that is sliding down is regarded as what? The angle of repose. You can see this is angle of repose. Do you get it? If it is resolved on this surface, if it is vertically, it's going to be what? Cos. And if it is horizontally, if it is resolved horizontally, it's going to be what? Sine. If you can remember one example that we solved in class, when I said is moving in a horizontal surface, if you can remember that is when we make use of F equals to what? F cos theta. If you remember, F equals to F cos theta. So that is because it's sin theta rather. It's because it is what? It is in a vertical horizontal axis. So if it is vertical, it will be what? Cos theta. If you can remember that example. So the same thing is applicable to this one. Okay? So that is that about the what? The angle of repose. Okay? Now, let's talk about the law of friction. Okay? The law of friction. Law of friction. Are you there? The law of static friction. The law of static friction states that the frictional force always acts in the direction opposite to that in the what? Opposite to that in which the body tends to move. That is, if we apply force to an object, the frictional force we apply we be in the what? In the opposite direction of the force that we apply. Okay? Now, the magnitude of friction, the magnitude of frictional force is equal to the what? Is equal to the external force. Okay? The magnitude of friction is equal to the what? External force. That is F equals to what? Equals to P. Now, the ratio of limiting force and normal reaction is constant. The ratio of what? Limiting force and normal reaction is constant. That is the coefficient of friction equals to what? Limiting force all over what? All over N. And it will be what? It will be constant. So that is what the law of static friction is trying to illustrate, and you must know all this. Now, the frictional force does not depend upon the area of contact which the two surfaces. Do you get it? Now, the frictional force depends upon the roughness of the what? of the surface. Do you get it now? The frictional force depends on the what? In the roughness of the what? Of the surfaces. Let me make use of tiles as an example. You know, you can walk easily on tiles, despite the fact that it's smooth, isn't it? That is that. But if you should pour water on the side on the tiles, and you say you want to move freely on that tiles, what will happen? Definitely you will fall down. What causes that? You have the what? You've reduced the friction. Are you getting it? You've reduced the what? The friction of the tiles. Do you get it? So if the friction has been reduced, definitely you won't be able to walk freely. Am I communicating? And or let's assume you pour oil, maybe engine oil, on the surface, on the ground. What will happen on the tiles? What will happen? You will fall down. Why? Because of the friction. The friction has been what? Has been reduced, and you will not be able to walk freely on the what? On the surface. Do you get it? Now we have series of examples on this. Now that is for the what? Law of static friction. That is if the object is at rest. Now what is the law of friction if the object is in motion? That is law of dynamic friction. The friction force always acts in the direction opposite that in which the body is moving. Still the same thing. The force that we apply, the frictional force will be the what? In opposite to the force that what? We apply. Okay? Now, the ratio of limiting force and the normal reaction is constant. Still the same thing. It is known as what? The coefficient of friction. We've talked about that. For moderate speeds, the friction force remains constant, but it increases slightly with the increase of speed. So, as the speed is increasing, the frictional force will also be what? Be increasing slightly. Are you getting it now? So that is also the law of dynamic friction. So thank you very much for that, and let's solve one or more examples on this friction generally. Now see this example. Are you there? A pool of 15 Newton inclined at what? Inclined at 30 degrees to the horizontal is necessary to move a wooden block on horizontal table. If coefficient of friction is what? Is 0.20, it has no units. Do you get it? The reason why it has no units is, okay, don't worry, we are going to discuss when we are solving this. It's 0.20. They now say find the weight of the wooden block. They say you should find the what? The weight of the wooden block. So in order for us to get this, you can see you have to sketch this. Are you seeing that? This is the block. This is the normal reaction. This is the weight. Definitely we have the what? This is the magnitude, which is what? 15 Newton. Are you getting it? And if it is resolved, the angle, if it is resolved here, it is what? So let's solve that before we can get this. The data given on this is only what? The magnitude. Are you getting it? Which is 15 Newton, and we are given the what? The coefficient, which is 0.20. Now, in order for us to do that, we have to resolve this horizontally and what? And vertically. Are you getting it? Resolve parallel to plane and resolve what? Perpendicular to plane. Then after that, we are going to make use of what? The friction to what? The coefficient of friction to get our normal reaction. Now, if you should resolve parallel to the plane. If you want to resolve parallel to the plane, you can see that will not be what? That will not be F equals to what? The magnitude. That is F equals to F cos theta. F equals to F cos what? Cos theta. So that means we are given this sketch on the question as well, which our theta is what? 30 degrees. So just substitute that. We have what? F equals to 50 cos theta, and if you press your calculator, F equals to 50 cos theta will give us what? 43.30 Newton. So that is our what? The force that we have on that block, the applied force that we have on that block. So far we've gotten that. It is very easy for us to get what? It is very easy for us to get our n, which is guided as what? The normal reaction. Okay, so that will now be what? Nu, the coefficient of friction equals to what? Force all over n. We are given the coefficient of friction. We know our F now. Just make n the subject, you will get what? 216.5. Okay, now if we should now resolve perpendicular to the plane, resolving perpendicular to the plane will now be equals to what? Will now be equals to n plus what? Plus F sine theta must be equals to the what? Must be equals to the weight. Are you getting it? We know our n to be what? 216.5 plus what? So if you find F sine theta will give us what? 50 sine 30 will now be equals to what? Will now be equals to the weight. Are you with me? Now, using calculator for 50 sine 30 will give us what? 25. That will now be what? 216.5 plus 25 will now be equals to what? W. Therefore, our W will now be equals to 241.5 Newton. Do you get it? So that is the weight that the question says we should find. Thank you very much for listening to this lesson. May Almighty Allah increase you in knowledge. Please, if you have any question, you can forward your question to me through the student response on the portal. And in my instruction, the note that I sent last week, you must copy it inside your notes exactly the way it is. And inshallah, immediately we resume, you are submitting this note. And it carries mark. That is one. Another thing is this slideshow, you must write all the notes as well. The slideshow, the way I splitted the way I simplified the lesson, you must also write everything on this slide on your notes after the note that I sent last week. Do you understand? So that is that about that. Thank you very much for listening.